So today we are going to do actually optimization of some simple molecules, and maybe if time is there, we can do NBO that you have just read. So get familiar with the interface. So you can see a blue screen is there. So you can make a new molecule. Just click over that click on the blue screen. What do you see? A methane molecule is there. Okay. So methane is there. So now you can proceed with that. But I'll brief you first. So we do not claim that we are very expert in this software. So if there is any mistake, so forgive us and please correct us because many people know Gaussian here. So now you've opened the Gauss view. So basically two parts are there: Gauss view and Gaussian. Gauss view is the modeling part where you can draw the structure of the molecule, uh, whatever kind of molecule is it. It is a stable molecule, it is a excited molecule, cation molecule. So you can make the molecule, and then there is calculation part, Gaussian. The two parts are integrated into Gaussian. Okay. So today we are going to do optimization. So what are the some pictures are there? Single point energy calculation, optimization. So what is the difference? We will also tell you that. And now Ragi will handle it.
Okay, so anyone who is not familiar with this software, what's you? First time we are all lots of people. So basically this handphone session is totally dedicated to all the new users who are not used this. And those who are already familiar, you should cooperate with the your colleague so that you will save the time. Okay. So first we have to make the first we will set a folder. So just click the uh, in the blue screen and save. Start the calculation, like right click and calculate, and the calculation setup. Anyone who is lagging, please ask because we have all peers also there. They will. Yeah, calculation setup. Yeah. If by mistake you click 2 times, it will add a 2 molecules. So better you can use the Control Z option. This behavior. Which is the drawing window with the molecule is there. Actually, it is the active that one. So, this gray window is the active window. Whatever the molecule is there in that window, when you click the left click in the blue window, it will add this molecule. Yeah. Gray window is the active window. Once you click in the blue window, it will add that molecule. Everyone is.
Anybody having any difficulty? Please ask.
So actually, first we are setting the folder in which all our calculation will save. So just click the right click on the blue window, not left click, right click, and go to the calculate and the calculation setup file. Calculation setup. Okay. So these have many tabs like job type, method that will be discussed later. But this is the default settings. Okay. So we will first save this setting as well. We are not going to change any method and any basis set. You just submit this one and save in your desktop folder. Okay, make a folder on your desktop with your name, PC, whatever the number, like PC 9, 10, whatever you have PC number in your desktop. It will be easy for finding the files. So you can go to the C drive, then user, chemical engineering, then desktop. So this is, you can write PC, whatever your number, PC 85. Actually, first make a folder here. C drive, user, chemical engineering, desktop. User. Oh, you can So go to the your new made folder PC 85 and write methane molecule. So this input file, basically in the Windows version, the file extension for the input is GDF, but in the Linux version, is .com is there. So it is a both. It will work here also. So you not need to write the extension; it will take automatically. Everyone is there up to. So now you can submit this job. So it will not take much time because it is the minimum basic tech and all the molecule is also given. So once the job is complete, it will show a question job is completed. You can close the window. So it will pop up a two base, output file. One is CXK shape file, another is the log file. So for the common analysis, log file is enough. But when we do the orbital analysis, that time we require that CHK file. So that time, this time you can open that log file. So it will show the optimized geometry because it is a very simple molecule already. It is optimized. So you got the log file? Yeah, you can open that log file. It's log. Take the modifier. Yeah. It is the optimized geometry. It is a very simple function already. Yeah, used to the optimized input file. It makes work. But later we will see the differences. We did this step because this is the common step of all the
बोलोगे I'm repeating.
So I'm repeating this step again. You can don't use even connect. Those who may have repeating again. Okay. We will get the so I'm repeating the steps. Whatever the molecule in the gray window is there, it is active window. Once you click the left click on the blue window, it will add the molecule, and you can go to the calculation setup. Whatever the default setting is there, keep it as, and submit this molecule for the calculation. So whatever the thing is there in the log file, we will just later with the molecule. Just take up for the how to open the Burpee and how to do the calculation setup. Okay. Engine.
What type of means
If you close the blue window, you can add the new molecule from that file menu. You can see that there's a ring fragment section is there. Okay. You just click there. So it will show a ring fragment section here. The by default it is selected benzene. So you have many different ring fragments. Okay. So we'll go for the default benzene. So it is already in the active gray window. So you just left click on that blue window, right? So this can be so we'll highlight basis for the that benzene molecule. And for that calculation, you can use the shortcut key Control G. It will go to the direct calculation setup. Okay. Go to the calculation setup. Right. In the first tab, you will see that a job type. So it has lots of different calculation. Like first one by default, it is energy, which is also called a single point energy calculation. Those who have done, can you say that why it is called single point energy calculation? Anyone? Energy calculation is why it is called single point energy calculation. That's just it. Why it is called the 0 point energy calculation? Single point. Yeah, sorry, single point energy calculation. Actually, it is not changing any geometry because it is calculating the energy at the single point. No any point of geometry is changing. So whatever the geometry you are putting it as an input, the coordinates will be the same after the calculation. But during optimization, the coordinate will be optimized according to the basic set and all these things. So we will do the optimization of this molecule. So in optimization, basically two types of optimization is there. There one for the global minima is called the air minima, and other is the for the transition state calculation. But today we are only focused with the minima. So use that, select that minima. So that and keep other things as a default. Okay, force constant, all these things, and go to the method tab. So the simplest theory level is Hartree Fock, but we have to do that on the DFT level, right? These have many other methods and theory of level. That is the theoretical part. I think Musarraf sir has covered a few parts. So we'll optimize this at the DFT level of theory. Yeah. And for the functional, we have also lots of different type of functional that you already maybe saw in the whatever slide. So we'll use the most popular one, basically. Why? Why we are using basically? Anyone? For the organic system, generally basically is giving good result, either for the reaction mechanism or for the interaction with the polar and non-polar molecules. So in the title section, you should write name so that you can, it is not read by the software. It is for your convenience that you can understand what the molecule is there. So in the next link section, for the Windows version, generally we keep as a default. It will take the memory limit and the CPU of the that system. But for the Linux, we have to, since we have on the supercomputer lots of nodes and CPUs there, so we can increase there. But here you can put it as it is. Yeah, in the method section, we have to increase the basis set because it is the lower basis set. So you can use that 631G. You can use the higher basis set, but it will take the time for the calculation. So we will use the average basis set, which is a 631G basis set, and submit this job. This time, since we are using DFT level of query and the higher basis set, so it will take more time compared to the HF method. So So now we will see the in detail what are the panels available in the Gauss view. Now this calculation is complete. Leave it as. So that part you are already familiar, that Gauss view interface, right? So in the panel, you can see that some elemental, some fragments is there for the drawing the molecule required, because each time it is not benzene and methane, right? You have to make your own molecule. Sometimes you have to add some, you have to delete the atoms, all these things. So we'll see that what are the this section is there. So you see this is the panel of Cosview that we are using, and this is in the manual. That this is the elemental, that from here you can choose the different element. So here you can see the by default it is showing the carbon tetrahedral, means CH4. You can click here. So you will have a periodic table there. You can choose any atom what your required is there. So in periodic table, in the below fragment, they have different hybridization of, depending upon the hybridization of the carbon. They have different fragments: CH4, means sp2, sp3, sp, and even the single carbon atom. So this setting is coming under the elemental segment. Whatever the elements you require, you have to choose from this periodic table. Can you please repeat? Okay, sure. So in that section, you see that one element fragment is there. So in Gauss view, here is the where you can see that once, yeah, is there. So this one is the element fragment. If you click there, you have this by default CH4 molecule in the gray window, and in there carbon tetrahedral is mentioned because due to this molecule. Now, if you click this, so after this, you will have the periodic table, and in the bottom section you have the different hybridization of the carbon. Whatever the molecule, if you select the oxygen molecule, it will show accordingly the molecules hybridization in the lower section. For the chlorine molecule, whatever is your requirement, you can check that molecule and draw this. Okay. So everyone is able to follow. Anyone is lagging? If there is any issue, you can call that PA any. Good. So near that elemental fragment, we have another ring fragment that we already done for the benzene case. So if you open the benzene, what it is written, you will see different, by default ring fragment is there. But if you need other ring fragment, you have to make your own. That we will discuss later. So similarly, you have, apart from this, that when you are putting your mouse, you can see that R group fragment is there, name is there, whatever the things is there, R group fragment. Here some formyl group and a ester ether, this type of group is there. So basically these fragments are helpful when you are adding some additional functional group, because otherwise you have to add each an element, join the bond, so it will save your time. So next is the biological fragments. Those who are working in the field of biology, these fragments is helpful for them, like for the amino acid and this type of aniline, salt, whatever that is required, you can use. Okay. Now you Please open a new window, new molecule window, and draw water molecule by yourself. Very simple molecule. Just close this periodic table. Go to the file. And make it smaller so that it will become easily for other section. So, this is a gray video.
So if I open the elemental to and go for oxygen, it will appear that by default it will calculate this. That's only one.
There,
Like I go here right now. And I click after.
Yeah.
And I click this.
Yeah.
So that's.
yeah, it will give wider.
But
Otherwise, you can also make the water from
molecule लेके उसके बाद आपको bonds बनाने पड़ते हैं.
Anybody having any difficulty in drawing water molecules?
So you go to the oxygen, elemental fragment and select the oxygen. So here the hybridization of the oxygen here is the sp3, right? Two lone pair is there. So you choose this. So it will automatically add the hydrogen in the gray window, and you same draw in the blue window, right? So anyone have idea what is the bond angle for that water molecule? 108. Anyone? Okay, so that we will see from the bond angle part. So here you can go. This is the modify angle for that you can modify the angle case. So you select this angle part, modify angle, and you select all these three items starting from hydrogen, oxygen. So it will give the by default whatever say 109.5. Right? So you are getting that bond angle 109.5.
That was from what I did.
Yeah. Just for an angle you will need 48. 35. So after selecting the modify angle, you have to select the individual atom. So starting from hydrogen, oxygen, then hydrogen. If you select from oxygen, hydrogen, and hydrogen, so it will give the OHH bond angle. But here we are interested in this bond angle, right? So we will understand what is the significance of optimization of this molecule. So it is the default angle. Let it change this angle to the 115. You can write here. And do the Okay. So it will modify angle 115, but we know that by default it is 109.5, right? Okay, now give the same optimization setting that we have done for the benzene. Go for the calculation. Use the shortcut key Control G because it will save your time. In the job tab, you select the optimization. In the method, you select the DFT and basis set of 631G. Title right name. Everyone is there up to there. Any issue? So one more thing you can note that whatever you title right, it is appear in the top here, and whatever you setting done that for that has opt is for the optimization. That from this line you can read that what are the calculation is there and what are the level of theory is there. That B3 leap is using as a functional, and 631G basis set is used for this calculation. Right? You can submit this calculation as well. Or you can close that input water molecule what you have modified. I'm moving fast or slow. You are able to capture. Definitely. I can do that. Now you open that optimized log file what you have just run, and again check the bond angle. What? 10?
108.358.
Yeah, but by default we know that
It's 109.
109.5, right? So this slightly but we modified up to the 115, but it is coming close to the 109.5 after optimization. And 108.3 is coming due to the lower basis set because we are using only 631, right?
Okay, so if we go higher, then it will-
Definitely, if we go to the higher basis set value, it will improve and coming close to the experimental
so
value.
it will come to 109 and then
Yeah,
109.
Everyone is getting there? Now these molecules are the by default it is water molecule. You did not modify it, any during making. So now open another molecule new window. And make a methanol molecule so that you can add the different section.
If I can just start to start. If not both anybody is able to
Now you can make a methanol molecule, right? Because methanol is not, I think, your molecule is available in the working window. You have to make. Anyone? What is the formula for the methanol? Yes. Yes. Go ahead. So you have to make the CH2OH, right? So it is you make the CH4 molecule, then you have to modify it and make it to the CH3OH. That is the answer. So you make a CH4 molecule. So since we have to make a CH3OH, so you can replace one hydrogen and put a OH. Right? One more thing I want to highlight there is in the gray window, you can see that carbon molecule is highlighted as a blue one, right? If you select the hydrogen atom, it will highlight the hydrogen. So what it means actually? Because it means that when you add the another molecule, it will connect from the carbon. right? If it is selected the carbon, everyone please. So if it is highlighted as a carbon molecule and you add, so it will add the CC bond, new CC bond, right? So like it is a ethane. So if you highlight the hydrogen molecule, now you connect, so it will see that hydrogen is making two bond with a different carbon, right? So it is not correct, right? So that is why here the highlighting in the gray window is important. So it should be by default carbon carbon. So now we have to add this different OH molecule. You go to the O section. You either take O atom or you take the OH and click on this hydrogen molecule. After selecting the OH, you just click on the one hydrogen atom. It will make a OH bond. Joining the bonds, everyone, those who are using, suppose for that hydrogen we required 4. So if you select 4 atom different, then you select carbon as a atom and select the C, then oxygen atom. So it is a very tedious task. Then you have to join each and every bond. So it is not a correct method. But bond can be modified and can be connected, elongated, what we are required. But basic good thing is you have to make the CH4. Whatever the basic functional group is there, you have to add the new functional group to make your own molecule, right? Okay. Actually, I'm saying that if some people are interested that in methanol, 4 hydrogen atom is there, right? One carbon and one oxygen. So you take each atom and join every like CH bond you are making every time, then CO bond making, then OH bond making. So it is a time consuming as well as it is not a correct method. Because that time you don't have the correct OH bond and yeah, so the optimization it will be there, but it is not a correct method. So everyone, I'm done. I repeat. So we are not going to optimize this molecule. It is just for that creation. And apart from this, you have different more panel like here. We already discussed that bond angle part, that how to check the bond angle between 3 atoms. Also the bond length part. Select this bond length part. You can zoom out using cursor, and this that OH bond is 0.96, right? Everyone is there up to the section is that modify bond, right? So suppose in case you don't require any bond between two atoms, you can here put that none and save as a okay. If you want double bond, triple bond, partial bond, and all this, you can do in the setting, right? So suppose you are modifying bond length for a single bond. So here atom one is you can see that number is there in the atom one and atom two. So you have option that which atom we have to translate, because if we increase the bond length, chances is either we can increase the both atom or we can fix one atom and other. So this option is there, like translate this group atom one and fix the atom two. So if you remove a cursor, see that in the blue panel how the bond length is changing, right? Same is you can translate atom and this one, and you can fix this. So this will go in the opposite direction for the other molecule, like atom. So this way you can modify the bond length, and bond order you can modify using either bond single bond or double or triple bond. And one more dihedral angle is there. Anyone have idea what is the dihedral angle? For dihedral angle, you have to select four atom because it is the angle between one and fourth atom, but it will select the one atom as the one plane and three, four atom is the another plane, right? So you can take 1, 2, 3, 4. It will give angle between 1 and 4 with 1, 2 as a one plane and 3, 4 as a another plane. So these are the modifying tools for angles, bond length, bond dihedral angles. So one or two or more things is there. This section is that delete atom. If you already have, you cannot close the all window. You just select this delete atom and you just click on the one atom. It will delete that atom. Control Z can be used for the undo. Here, this selection panel is there. You can use this panel as a to select the individual atom. Go to this select atom by clicking. It will highlighted in the yellow. Similarly, if you double click on the same atom, it will unselect the atom. So these all are the selection tools. Like here, you can select that by dragging this one, selecting all atoms. This will be helpful when suppose you have a large molecule, but you want to delete some part of the molecule. You could not delete every atom, so you better to select in large area, and you can do it. Similarly, this section for the unselect all atom, select all atoms. So these are the all the modifying tools which we are seeing here. So for that panel part, whatever the Gauss view panel has, so whatever the panel is there, so it is over part. This part, the panel view, whatever the Gauss view panel has a different type of setting, like builders in there. And suppose anyone have mistakenly taken any molecule from different sources, like from the internet, you have downloaded and put it. So that time you can, it is advisable you can do that clean part. So if it will automatically means arrange the molecule in correct order. If you slightly modified angle more than whatever the default value, so it will useful that time. So up to this, any problem is there by understanding the what are the panels and the what are the modifying section is there for the work section. So this will totally dedicated for the new students. We'll stand here in the first view. Anyone? Any queries? If not, then we will just have a short break for the tea. Then we will continue after the tea. Okay. Yeah. So after 15 minutes, we'll continue the part. Okay.
Drafting of paper.